Okay, good morning, everybody. Yes, welcome to this IoT and innovation stage. My name is Diego Galar. I'm professor at Luleå University of Technology, and I'm going to be with you as first speaker of this session, and I will be with you during the whole session as chairman of this session. And I hope that you enjoy this industrial perspective of the IoT and innovation stage, and we can have fruitful discussions, presentations, etc. Then, during this presentation, we will have, during this stage, we will have, as the rest of the sessions, 2 breaks, one for lunch and one for coffee, and then we will, the session will last for these 2 days until tomorrow by lunchtime. Then, let me start, because we have a very tight schedule, really exciting agenda with many speakers, and I have the pleasure to be the first one to warm up the environment in terms of artificial intelligence, IoT, and industrial aspects of this revolution. Then, let me go to the point and start with the presentation that is some kind of introductory framework for the rest of the sessions, okay? For me, it's interesting to start with this industrial AI for manufacturing in order to see the real applications that in a country like Sweden, industrial AI is having, and what are the challenges that we are going to face, and the next speakers are going to talk about that. Of course, the digitization is coming to the industry in a very strong way. We have digitization in such a way that is so strong, and we have the Industry 4.0 as one of the main drivers of this digitization. In this regard, we have to be aware that manufacturing is the sector that is producing more data in terms of digitization. There is far from the rest of the sectors producing a huge amount of data. And in this aspect, the digitization in manufacturing has evolved in such a way that we have moved from the smart factories where we were deploying sensors to the digital factories that we are having some virtual assets that we are going to monitor and see how these assets progress. What I mean is that we are moving from the physical assets to the virtual assets, and this is a huge evolution in our topic. What do I mean with that? What I mean is that we are talking about factories and industry that is moving from traditional manufacturing to digital manufacturing in 2-3 years. The evolution is such that from instrumentation, interconnection, and intelligence, the time frame in 2 years, we can have totally digitized factories. And this evolution has come to sectors very conservative like steel, mining, etc. And you may wonder, what is the role of AI in this? The role of AI is in artificial intelligence adapted to the needs of the industry. Artificial intelligence, as the keynotes said in the beginning, is nothing new. But now, with artificial intelligence adapted to the industry, we have the chance to have a specific context where artificial intelligence is growing so fast and augmenting the decisions and the brain of our people. And of course, maintenance and operation and production are one of the biggest beneficiaries of that. Indeed, in maintenance, the maintenance powered by the artificial intelligence is one of the main beneficiaries. And we have to be aware that in this case, the artificial intelligence, together with the engineers, we have to co-create a solution in order to have something together. What I mean is that the artificial intelligence cannot replace the traditional engineers, but both, they have to work together to co-create a solution. And this solution has to be something that is going to do 2 things. Improve the performance of our assets and decrease the shutdowns of our machines. Because at the end of the day, the 4.0 revolution is about that. It's about increasing performance and decreasing the number of failures. And now, we have to be aware that we are changing the way to do the things. In the past, we have done traditional models, mathematical models, and doing some kind of anomaly detections, warnings, and have some alarms. This is no longer valid. Now, the anomalies that we have to be aware that the artificial intelligence in industry has to cope with different things. We have not just point anomalies. We have to work with contextual anomalies, with collective anomalies, just for specific frameworks like the industry. And of course, in the industry, let me be honest, the biggest enemy is the false positives and the false negatives. If we have many false positives, means that we are going to do actions where the action is not required. And then the performance of the artificial intelligence will be gone, and the confidence on the system will be gone as well. And what are the biggest enemies of the artificial intelligence in the industry, the industrial AI? Two enemies, the black swan and the swan song. What is the black swan? Black swan is this kind of rare events that we don't have in our data. And suddenly, these data pop up and they create catastrophic consequences. And when these events happen, suddenly we find an explanation for that. But they were unpredictable events. This is the black swan effect. And the swan song is the other way around. Shall I be able to predict when the machine is going to shut down? The swan song is when the machine is going to die, is going to pass away. There's any sign that with the artificial intelligence I can detect in order to plan the shutdown and not having catastrophic failures. These two things are the biggest enemy of the performance of my AI system. And in this regard, we are working in a risk perspective, and we have to be aware that we have the data, we have the knowledge, and we have the surprises. And this is where artificial intelligence has to fill that gap, the surprises. What we are doing now with our brains, with our computers, is something probabilistic. But the artificial intelligence should fill the gap of the surprises. And how we can do that? We have to find a tool. And the tool has to put all the data we have together. In our companies, we have a lot of data together. We have SCADA data, we have ERP data. And for that, the only way to put everything together and run our industrial AI systems is to create the digital twins as enabling technology. The digital twin suddenly becomes the tool, the enabling technology to run our AI systems. And the digital twin is something that we are going to use as a data repository, as a model, as some kind of virtualization of the asset in order to do these two things. Improve the performance, reduce the number of failures. And for that, the connection with the business is essential because we are putting all the data that we have in our digital twin, and we want to show our business KPIs out of this digital twin. At the end of the day, the digital twin becomes the virtualization of our asset. But the digital twins have been evolving very hard. We have the digital twin 1.0, basic machine learning. You put the OT data of your asset, the data that you are collecting from the sensor, and you put in a normality, normal behavior, anomaly detection, and you run it. This is the most basic stuff you can have. The digital twin 1.0, where you have just the OT data. OT data just to detect anomalies and deviations from the normality. It's important to notice that the digital twin 1.0 is something just based on OT. OT, the technology that is close to the asset, is a digital twin based on OT. But what about the IT systems? We are talking about IT systems like ERPs, CMMS, etc. The IT systems must be combined in this digital twin. And for that, we have the different evolutions of the digital twins. When we bring to the digital twin the taxonomies of our assets and the ontologies, it means all the databases, all the connections of the happenings of our asset, suddenly we have the second family of digital twin. When IT and OT converge, when we have the convergence of the technology close to the asset, together with the technology, the IT, the managerial technology, when both IT and OT converge, suddenly we have the digital twin 2.0. That is the data that we are acquiring from the asset in real time together with the data that we have in our IT systems that is producing something that we call the Digital Twin 2.0. The Digital Twin 2.0 is the convergence of IT and OT technologies in order to produce metadata of data much richer in order to be exploited later on and be able to evolve in that. But not only that, the Digital Twin 2.0 still lacks many things. The Digital 2.0 still lacks many things because we have one limitation. The limitation is that we are not using all the data that we have in the organization. And in the organization, we are getting so much data, and we are making sense of so less data that we need something else in the evolution of the digital twin. And the evolution is the context. All the data that you are collecting in your systems, but is not related with your asset. When we bring this data, the data of the context to the asset, and we relate this data, and we create the concept of context awareness, very popular in aviation and different domains, suddenly, when the concept of context awareness means all the circumstances related to your asset described by the data set that you have, suddenly then we have the digital twin 2.1 or 2.x. 2.1 or 2.x in function of the amount of information that you are bringing to your asset. This is very relevant to see how the digital twin is evolving. But not only that, the digital twin 2.x with the context still has some limitations. What are the limitations? The limitations is that still there are some failures, that some performance that is not able to be predicted. Then what to do? If I don't have enough data to predict my failures, to predict my performance, if my digital twin 2.x still lacks performance, what can I do? If I have my data just about normality, 99% of my data is just normality. If I don't have data of higher stages of degradation of my assets, what to do? How can I fill the gap of the data science with artificial intelligence? The answer is clear. We have to go for something that fills this gap. What do I mean with this gap? When you are running in the industry your assets, you are running always in the comfort zone. You never take the assets to stress areas. And in this regard, this is important, because what we are bringing here is something to avoid the black swan losses. What do I mean with black swan losses in the industry? If something is not in my data set, I cannot predict it. And this is a limitation for me. If a failure is not in my data set, I cannot make the prediction of such failure, and this failure suddenly becomes a black swan. Then how to kill this black swan? I have to go to a mix of data together with physics of the failure. And these things together is what I call hybrid models. Hybrid models is where the artificial intelligence is running models together, physics of the failure together with the data sets that we are collecting in the field. And this tuning of the physics with the data and the data with the physics is what we call the digital twin 3.0. Because what we are moving with the artificial intelligence in industry is towards a digital twin where the physics of the failure together with the data collected in the field merge together and create the concept of digital twin with a PLM approach. What do I mean with PLM? Product life management. Physics of the failure from design and manufacturing, data from the end user. Together is what we call the digital twin 3.0, and this is the most sophisticated digital twin that you can find now in reality. At the end of the day, the digital twin 3.0 merge the data from the field, the physics of the failure, the context, and creating hybrid models with context data in order to deliver context-driven services. This is what we call digital twin 3.0, and is where the OT close to the asset, the IT close to the management, merge with the ET, the engineering technology that is the physics of the failure, the knowledge, etc. And how can I create this 3.0? This digital twin 3.0 is not difficult to create it. The only thing that you have to be aware is what are the limitations of your data sets. Be aware that in your data sets, you don't have everything. If you are aware of that, you will not have problem with that, and you will be able to do a complete analysis, deep analysis of your failure, and the ones that are not there, we have to find a way to fill these gaps with physics of the failure. Means that the digital twins 1.0, 2.0 are useless? No. The 1.0 is very nice in the operational level for warnings, for early detections. The 2.0 is very nice for different actions in edge computing, in the tactical level, to do some kind of operational maintenance. But the 3.0 is something else. It's something in the higher level of strategic management. But what do we expect of these digital twins? Because at the end of the day, the digital twin is one enabling technology, and we have to do something with this digital twin. What are the expectations of this digital twin? The expectations of this digital twin is to have a virtual commissioning of our assets, a digital asset that is not just a data repository where I have dumped all the data. What I need is to co-create this model of artificial intelligence of all the databases together with my physics of the failure in order to deliver some services. And it's important that the evolution of the digital twin is going to deliver the different types of analytics, of the analytics of AI in industry. Because if we go to the past, so far, what we have done is descriptive analytics, diagnostics. And diagnostics is just to see failure 1, failure 2, normality. This is pure clustering, classifiers, is nothing new. But if we go for the further stage, predictive analytics, okay, let's go for that. What is that? Is to predict how the failure, when the failure is going to happen. And this is, okay, this is maybe more sophisticated, but we have already overtaken that. We know when the failure from normality is moving and when it's going to happen. This is predictive analytics, and this is also overtaken. The thing is, okay, next step, prescriptive analytics. This is what we want. What is prescriptive analytics? Prescriptive analytics is, okay, if I run my asset in one way, the gradation will be like this. If I run it in a harder way, the gradation will be harder. This is prescriptive analytics. This is what we want. Actually, no. The prescriptive analytics is already overtaken as well. The artificial intelligence in industry now is moving towards cognitive analytics. Or everything that I have been showing regarding analytics, even the prescriptive analytics, when I know that one asset is performing on the grading in some circumstances, this is due to my knowledge, and I'm introducing this knowledge in the system. But now, the AI in industry has to be able to be autonomous, and the cognitive analytics, that is one step forward, has to go much far away from this and learn these prescriptive rules in autonomous way in order to be prescriptive but autonomous at the same time. Then, as a summary, let me say, just to summarize my presentation, that it's important to see the evolution of the digital twins and to see the gaps of data that you are having in your digital twins to kill your two enemies. The black swan, that is the terrible thing when you don't have records of your data, and in order to overtake the swan song. The swan song is the Achilles heel of our systems. And of course, when you move from the traditional analytics to the current analytics, we have to be aware that now prescription is already overtaken. 2-3 years ago was maybe the main goal. Now we are moving towards cognitive analytics, and AI in industry plays a key role there in order to have cognitive analytics like prescriptive but in autonomous way. Thank you very much.